Now let's look at properties of inverse trig functions. Now, we're going to focus on y equals arcsine of x. We say y is arcsine of x if and only if the sine of y is equal to x. Now we restrict the domain to be between -1 and 1, and that restricts the range to be minus pi over 2 to 2 pi over 2. Now another way to write arcsine, because this is too much work to write, it really is, we write it as the inverse sine of x, and you'll see me flip between those two notations. Now here is the graphs of these 6 primary trig functions. And inverse sine is defined between x equal -1 and 1, because sine, the range of sine is between -1 and 1. You need to study these graphs. Now, we say that sine of arcsine is equal to x, and arcsine of sine is equal to y, because these are inverse functions. And the same is true between tan and arctan, and secant and arcsecant. Now, how would I go about finding the arcsine of an angle? Now, arcsine of -1/2 literally means, it actually means that the sine, this equals y, implies that the sine of y is equal to -1/2. Now, what angle do we know has a sine of -1/2? Well, of course, minus pi over 6. This is an angle, and so you have to remember that. Now, what if we want to solve problems? Suppose I have or the inverse tangent of 2x minus 3 is equal to pi over 4. How would I solve this? Well, the first thing I want to do is take the tangent of both sides. So if I take the tangent of the inverse tangent of 2x minus 3, this is equal to the tangent of pi over 4. Now these are inverses, so this leaves me with 2x minus 3, and the tangent of pi over 4 is of course 1. So this is straightforward to show that x is 2. So the inverse tangent of 2x minus 3 equals pi over 4 has a solution of x equals 2. Now, what if we get a little bit more complicated? What if I tell you y is the inverse sine of x, and I want the cosine of y? What do I do now? Well, I draw the triangle. Y is my angle, right here, and y is equal to the inverse sine of x. Well, if I apply the sine to both sides, I get sine of y is equal to x. Now, if sine of y equals to x, then x is over here and 1 is the hypotenuse. So I have sine is opposite over hypotenuse. And if this is true, because it's a right triangle, this side right here has to equal the square root of 1 minus x squared. So for all of these problems, you really need to finish your right triangle. Well, if this is my triangle, what is cosine of y? Well, to find the cosine, of course, that's adjacent, which is the square root of 1 minus x squared, divided by hypotenuse, which is 1. So the cosine of y is the square root of 1 minus x squared. Now let's look at a problem that involves secant. Suppose y is the inverse secant of the square root of 5 over 2. What's the tangent? Well, if the inverse secant is square root of 5 over 2, let me take the secant of both sides. The secant of y is the square root of 5 over 2. So the secant is, of course, 1 over the cosine. So the cosine of y is 2 over the square root of 5. So the adjacent side is 2, the hypotenuse is 5. This side has to be the square root of the square root of 5 squared minus 2 squared, or 1. So this side is 1. As soon as I've drawn my triangle, I can find sine, cosine, cosecant, whatever. So the tangent of y has to be opposite over adjacent. So 1 over 2.